Test, much better. I think in the recording from last time, there were no recordings because Dr. Khan typically doesn't teach at this class. So how was the meeting with him? Okay. Okay. Yeah. Thank you. So what are we going to do in the remaining 3 meetings? Hello, Mel. Thank you for joining. So there was a little bit less meetings than expected, but we need to complete this 2-month story of pleasant acquaintance with good memories and good grades. So we need to leave a little bit of baggage in your memories for the second part of the class. So there is absolutely no chance to do everything if I continue standard lecturing, but I have suggested and you accepted that we do like a little bit of self-learning. So basically, let me just tell about the future, and then we will do some exercises here. So I suggest that the whole next week will be your presentations. Do not fear. The presentations will be short. I will be assisting, and for the grading, I shouldn't say it. I should microphone unmuted. The fact and effort is superior compared to the quality, right? It doesn't mean that do bad presentations, but just to encourage you that you do not fear like, oh, he's making us to make his work and teach lectures instead of himself. So we will do 2 series of presentations because we have only 2 meetings left, right? Then Professor Burkhaus will start statistical mechanics with you and thermodynamics in whatever 2 weeks, like starting March 7th, right? So when is the spring break? Well, let's do this little expedite thing. If I miscounted days and we get extra days to meet, I'll find some pleasant activities for you, like entertain you with something so that it will be, you will not regret. But just in case, it's better to complete things ahead of time, and so that we live simple and like concentrate now and relax after, right? If something doesn't happen, we'll postpone or whatever. But let's try to live intense life. So many thanks for practicing democracy and selecting theoretical subjects. So I suggest that on coming Monday, everyone will present the subject that he or she selected, right? And again, here is the idea. Do not try to impress me. I'm already impressed by your performance. If you just come and mumble something, it will be enough credit towards your grade. Try to impress the class. So there is, I'm not setting this up. There is an objective difficulty with this scramble schedule that projects are really helpful because they develop long-term memories and practical skills. Whatever you do on projects, you will not forget for the rest of your life. The academic information, I know that many people, you are teachers yourself. You know that undergrads can use their heads as a little bowl, where you pour information, carefully bring it towards exam, and then dump it, right? It's very standard, and it is not that the people are bad. It's just the bless you, just the shortcoming of this academic style of learning and giving exams. But if you will try to summarize most impressive and interesting part of your theoretical subject in a way that the rest of the class memorize it, not for the rest of the life, but for the next 2 months, to impress Dr. Burkhaus. Okay, so whatever you can squeeze in 5 minutes, not in the sense like make it dense, make it something that the rest of the class can remember after. Since majority of you are already advanced teachers, just show your best teaching skills, teach each other this subjects, and talk to me by emails in privately. I will assist. I think the information, the materials I've sent are more than enough, and probably the question is how to reduce and what is leave out and what to concentrate on. Do you think it is reasonable and possible? Any questions about this little theoretical exercise? So let's quickly review what your subjects were. So postulates of quantum mechanics. Oh yeah. Then evolution operator. 3 ways to predict future. I know Lolo is capable to do it. Observables, expectation value of an operator. No one selected it, but it will be briefly covered by Ariane. It is one of the postulates. Electron in a free space. Zoe. It's like a lot of information, but talk to me. It's my favorite subject, and I will help you if you find it complicated. Particle in the box, 1D energies. It is the easiest subject. I have no doubts that Haley will do it in the best way. Particle in a 3-dimensional box. I don't know if Steven has connected, but I'm aware that he's aware of this subject. And this subject is a direct connection to practical research in nanoscience. Okay, harmonic oscillator, Abdullah. So the materials I did send, I don't know if you were trying to look through, are oversimplified. Like there are books on oscillator, but if you start from basic things and just summarize like energies and eigenstates, I think it will be enough for the next course. And the subject that Abdullah agreed to present is most useful for the second part of the class. I promise there will be reference to the information. So you have a big responsibility. The whole class depends on you. Hydrogen molecule, bonding, antibonding. So for the MEL, it is basically a summary what we did last time here. And if it is not 2-dimensional, but regular hydrogen molecule, it is in Wikipedia and in all textbooks. If you need additional information, just send me an email. I'll provide, but it doesn't need to be much. Okay, and I'm also selected as sweet spot. You can just take a couple of slides from our lecture on Frank quantum factors and just tell your vision of like dipoles and how they're related. So it's, and the easiest subjects are by Amos and by Haley. So congratulations on smart selections. So then I do not know how to spell Coulomb. Coulomb. I can tell you my first experience of trying to speak English to native speakers right after I came into the country. I knew from academic education that so it's not about science, it's about how to spell. There is a letter U, and if you are not a native speaker, I do not think there are strict rules. So depending on exclusions, one sometimes pronounces it as U, sometimes as A. And hello, Steven. Nice seeing you connected face to face. So I came to the store to buy pickles, but I didn't knew this word, and I requested salted vegetables, but I didn't know how to pronounce it because there were 2 letters U. So I tried it. Give me salted cucumbers. What? Give me salted cucumbers. So same story with Coulomb. What do we do next Wednesday? So this is also doable. Just do not panic, do not worry. We will try to do presentations of the projects that you haven't completed yet. But we'll start to do as much as possible today. And if I learn that we have an extra days before the spring break, we will try to postpone and prepare more. But let's plan on next Wednesday as a to energize all of us and do something. Right, research presentations. Yes. So I really wish we have additional days before the spring break, but who knows? Let's plan this way. If there will be some simplifications, then we'll use benefits. So there are 10 subjects and there are 9 people because there are 2 hard subjects. So if you hear difficult subjects, you can try avoid 3 or 10. The rest of things are quite easy. So just try to write in this document. It is the same document where you did a sign up. So what do we do in the projects? Oh, Steven, you are not on the computer, so I need to help you. You can come here and type or just tell me if you have specific selection. But let me give a little overview what is the plan and how, what are we doing? So we are studying the photodissociation of molecular hydrogen, which is treated in 2-dimensional world, right? Right? It is what we did when we started the course. Yes? No? Okay. And the exploration of what happens to molecule after ionized to the hydrogen, what happens to molecule after it is promoted to excited state due to light to matter interaction, depends on the curvature of the potential energy surfaces, right? But we can find in a textbooks or online what are potential energy surfaces for regular 3-dimensional ionized molecular hydrogen, but it's not available for 2-dimensional. Therefore, it is a little setup and challenge. And your effort with Dr. Han right on the last Wednesday was intended to extract potential energy surfaces for this exotic hydrogen in 2-dimensional world. Yeah, thank you for doing it, even being away from the class. I saw it on the file and appreciated much. So today I am going to introduce a code that does fragmentation, the separation of these hydrogen ions, and will show as they depart over time. So this code will be a summary, everything we learned or not learned, or we wish to have learned, right? To those who was traveling to a conference, I'm forgetting to think. Let's me give a little announcement. One of your class attendees got an award for outstanding science at the Computational Chemistry conference last week. So her name is Haley, and please join me in giving her a round of applause. Yeah, very impressive. The code that we will get through today, that will be the main part of your project, was also awarded. Maybe not the code, but the person who was doing it. So it's this undergrad or high schooler, Samir. So he got his award for developing and practicing this code. So you will be dealing with award-winning code. The potential energy surfaces are input parameters to run this code. And the biggest, the code itself does work, but the biggest challenge is to establish connection between your effort in previous week to extract potential energy surfaces and actual dynamics in these potential energy surfaces with this award-winning code. So my plan is to introduce the code to you so that you feel comfortable with it, which is guaranteed because it works and it will work on your computers. And then after I'm confident that you are okay with it, we will focus on the hardest part, on how to convert the data into potential energy surfaces. I'll probably need to, I will need to write something on the board or type, but let me cover things in a freestyle speaking so that you get a basic idea of what we are doing. So the code needs the values of potential energy surface again and again instantaneously. The code for so-called wave packet dynamics. But you have experienced in either working at home or doing it together with Dr. Han last time, that extracting even a single point for this potential energy surface is very laborious. So we cannot follow Mother Nature and do these things together. Move atoms, recompute, move again. We better recompute all positions of atoms, create a potential energy surface, and then feed it into the wave packet code. Does this idea make sense, or you want me to speak more? Thank you. So the wave packet code that we didn't start yet, but I promise it will be done with guarantee, uses information about dependence on potential energy of these two ions on the distance. And this potential energy surface is different in ground and excited state. So the best way to describe it is to find a mathematical function that would correspond to this potential. The simplest function for potential energy surfaces are harmonic oscillators. But harmonic oscillators never dissociate, right? They're symmetric. As far as you elongate or contract, you have higher and higher potential wells. And we need potential well that gets to dissociation. I cannot pronounce it. Oh, thank you. Dissociation limit. So there is an expansion of or generalization of interatomic interaction that is generalization, which is more general than harmonic oscillator, and it is called Morse potential. So Morse potential is a mathematical function which is composed of like exponentials and fractions, which covers all features that we need. And interaction between any pair of atoms can be quite well fitted into this Morse potential by selecting values of 4 parameters. So our practical and most challenging task would be to get the data that you generated last week, plot them maybe like X distance, Y is energy, then plot the Morse potential and tweak parameters until these two data sets will coincide. And then these parameters are fed into the wave packet code and we run it. Is it a little better, or you want me to use maybe different words? Okay, okay. Steven, what is your choice, or what is left? Okay. Oh yeah. 10 is a little easier. What? But you feel free whether you want easier or harder. Okay. Let's type. Okay, and someone is chatting. Yeah, sure, Mel. It was just self votes, and I see you already took it. So before we go to this practical things, let me overview this typings once again. So the choice of Ariana is the first code that we were running, right? When we didn't add the second hydrogen, and we get set of eigenstates, have orbitals like s, p, d, and telling a little bit more what they are. Transition energies and lines. So this relates to the same code, same version of the code that Ariana was talking about. And for experiment, for astrochemistry, right? It is for spectroscopy, it's most important not the absolute values of energies, but their offsets. Like ground state minus first excited minus second excited, or first excited minus second minus third. And it is related to our very first meeting when we went over hydrogen atom, when we were doing a little experiment and you found these lines. So you may try to make connection, just find this transition energies, right? Convert them into maybe nanometers and tell what will be the color. Like if you would live in two-dimensional universe, what would be the color of the Orion Nebula? Would it reproduce pink, or it will be far in the UV? So just analyze outcomes of this simulation. Compute transition. So the one that no one took, which I completely respect and understand, but just tell for the story. If you would really want to reproduce actual spectra of this two-dimensional hydrogen ion, we would need to compute the thing that Amos will teach us next Monday. Matrix elements of the dipole operator for each transition that Zoe will be presenting. And it is doable. If I would be in the class, maybe I would select the subject, but it's since no one selected, it is making the position operator in two-dimensional space and then multiplying it on the initial and final wave functions, making this matrix element. It's doable, but in the short time, maybe it's wise that no one took it. And this part is not in the code. It means making additional things. Therefore, it is more complicated. So hydrogen molecule. So I will continue my disorganized talk further, but let me give a little heads up and reference to what we practically will do today. So I will cover the code that I did send to everyone is related to subjects 9 and 10. And the parameterization of this code based on your previous week work is in the rest of the subjects from 4 to 8. So when you collected data last time, I wasn't in class. I don't know what you were talking about, but I wouldn't be surprised if someone would raise hand and tell, I am confused. Based on the data that we collect, this molecule will never dissociate. So let's quickly look at the data that you have collected. It generates a suspicion. I know how to resolve it, but let's just look on it. So here are your data. So we look on the as we go from the top to the bottom, we depart to protons more and more further away, right? And when they're close, it is very negative. As we go away and away, it is less and less negative, but still negative, right? Or no, it's never positive. So let me check. There is someone is in the chat line. Just checking what it is. Oh, it is the same. So if you would plot your data, and if time allows, we'll try to plot it today. It's my wish. I cannot guarantee that time will be sufficient, but it is a wish. Wow. See why she got an award. Some of the numbers have something. That's okay. That's okay. But we need to resolve several issues with data. They're good data, but I need to learn more how to interpret them. And I have a little bit of understanding that I want to communicate to you, and we all will feel better with this. So can you share screen if you are on Zoom? I'll stop sharing and Haley will share. Stop sharing. Oh, you're not yet logged in. I'll double check if you are co-host. Yeah, thank you much. It's a great help to the whole story that we are developing. Do you have the link, or you no? You need me to resend it. Okay, let me try. To oh yes, that's a great idea. Thank you. Participants, invite, copy invitation, and then I need to get to mail, compose. Okay, maybe it will be quicker. Let's check. Not yet. Okay, thank you, thank you. Aha. Okay. And co-host, you're already co-host. Okay, perfect. So please share screen just for your slide. Okay. So bond distance, and it's a little strange. Ground should be always lower than excited. Maybe it's like red is E0, black is E1. Huh? Oh, yeah. But based, if this would be our absolute ultimate potential energy surfaces, it means that no matter what is the energy, it will always damp closer to the they will just fuse together, or they need to rotate really quick to stay away from each other. So we would need to maybe include very high rotational energy, which we know it typically doesn't happen. Rotational energy in real life doesn't contribute much. So it's based on this potential energy surfaces in two-dimensional world. There will be only black holes where all atoms collapse together, fuse, and no stable chemistry. But we did miss, or I didn't instruct you to include an important addition. What are the charges of the protons? Positive. How do they interact coulombically to each other? Repel. Did we include the repulsion in this eigenstate energy? So in fact, to get potential energy surface, we need to add eigenvalues that you have collected and the Coulomb repulsion as function of the distance. So the Coulomb repulsion on this curve would be infinitely high at 0 bond lengths and then slowly decreasing. So then it will convert both of these lines into potentials with minima, right? So Haley, would you like to stop sharing? Many thanks. It's much appreciated. So I'm going to share and just bring back the list of subjects. So subtracting, well, I wouldn't say subtracting, just adding or taking into account. It's a little delayed because of Zoom. And so well, what we discussed right now is basically your subject, right? Make sense? Okay. And I think it agrees well with other course that you're taking, right? Where potential energy surface is addition of the electrostatic repulsion of ions plus eigenstates of electronic subsystem, right? Okay. So this one is not the hardest in doing, but it is like most unusual and needs thinking out of box. After we're done with this philosophical idea that we discussed now, but we will re-deliver it to us in a week. The rest are a little more straightforward. So if we generate potential energy surface, if you just do what all instruct us, we can find at which distance this molecule will be stable if it is in electronic ground state, right? And you can compare it to the equilibrium distance of the real hydrogen in real world. Will it be shorter or longer? What if we are in the excited potential energy surface? Will it be shorter or longer compared to the data from Hamidou? Will be longer or shorter compared to three-dimensional world, right? Just locating the minimum where the first derivative gets to 0 and looking for the value. Okay, now Haley got a chance to do something not the easiest. Well, it's not the hardest, but not the easiest. And it is what I would like to do myself today, if time allows, after we get introduction to the code. So suppose we have added Coulomb repulsion. We got potential energy surfaces in numerical form. But then, as you will see shortly by looking through this wave packet code, we need just 4 numbers that parameterize this Morse curve. And it is a standard fitting problem. So to find such parameters of the trial fitting function that would match data set at most. So Haley will share her experience or her attempt to generate these 4 numbers for ground and for excited. Possible? Yeah, thank you. And as soon as you complete this data, please share them with Mel and Steven. They will use as an input. So Mel and Steven will not be able to do their projects before they hear from. So and we all will be working as a team. And again, time is too scrambled. I'm not making promises, but potentially what we do can result in like peer review paper with like 10 authors or 9 authors if you don't want to include me. Okay, and the last 2 subjects will be just running the code that I'm going to introduce now with help of data that the rest of the class generate. So we do have about half an hour. So I'm not sure if there will be enough time to cover number 8 together, but I want to do the best possible job on introducing the code. So first, I will show a couple of slides. They are maybe obsolete, they're from previous years, but it doesn't need running the code. And after we get general idea, all of you please open MATLAB, run the code, and you'll get acquainted with the structure. So when you need to change parameters, we will get through easily. So I think you were already opening the slides that I did send to you. Let's maybe do a little presentation. So these 2 figures are an outcome of the code, of the running of the code. The parameters that we extract determine what is the minimum, what is the curvature, and both of these lines, ground and excited, here the parameters are different, not those you will be using, but both conservative curve, which corresponds to the stable molecule, and dissociative curve that corresponds to just breaking on the pieces. They both are Morse potentials, just with slightly, or not slightly, with different parameters. So I will introduce the equation, but it's more important that we have general understanding of each other. So these curves are input parameters. Then this dashed line is the wave function, nuclear wave function squared, probability that the interatomic distance will be exactly at the minimum, a little to the left, a little to the right. Right? So probability distribution. And if we are in the electronically ground state, the molecule has vibrational ground state, which would correspond very much to ground state of harmonic oscillator that Abdullah will, I hope, present on Monday. But if we use information from Amos, and if we practice light-to-matter interactions, we promote this model from ground to excited state, the interaction typically takes short time and the shape of the wave packet doesn't change, but it goes from one potential energy surface to another one. So right here, the first derivative is 0, so it is stable. Right above this point, for the excited state potential energy surface, the first derivative is not 0, which means there is a non-zero force. And typically, the slope drives this wave packet away from the center. So the way to analyze the science from this code is to see what happens to this dark solid black as time goes by. This is best represented by movies. But if something doesn't work with movies, one can make a snapshot of this line at different time steps. So this color code on the bottom is matching the top figure. So the x-axis corresponds to bond distance. This colored stripes correspond to equilibrium, and y-axis is time. So as time passes by, we start in ground state, then at about 7 femtoseconds when for the excite, and it starts moving from left to the right. In this specific simulation, there were some other events. It was a second pulse that was bringing system down. So it's more what Stephen did sign up. And then it may return back, but it is kind of more exotic situation. In the situation that Mel will present, and we all are interested as our primary effect that happens on stars, that this little trajectory, when upon photoexcitation, it starts moving, and departs. There are some additional exotic phenomena, and it makes this problem interesting and publishable if we all as a team decide to go forward eventually. Okay. The other figures just show examples of the similar experiments and potential energy surfaces for another molecule. So it's a standard way to think about photodissociation of small molecules on this language. In this, in our three-dimensional world, potentials are known for basically anything, and one can spend like $500,000 by femtosecond laser and practice these experiments, or just use MATLAB license and just simulate it. Okay. Yeah, I was pulling this pictures from different recent publications. So people are using it for different set of molecules, and it is a standard way to analyze the dissociation processes. And here is stuff that I do not need to understand because I do not have experimental background. So it is how the actual experiments are happening. So there are chamber with molecular jet. There are trains of pulses, and then in this chamber there are high voltage capacitor that would accelerate the fragments, and then they come away through a slit and then analyzed on the mass spectrometer. So if it is not just two protons, if it is a bigger molecule, it may go into different fragments. Okay. Yeah, I think so. This is a typical result, which with slightly different parameters I would expect from the presentation number 9 from Mel. So nothing, and then accelerating and departing. Make sense? Just generally. Okay, and now let me. Okay, yeah. Here is just the visualization of the working code. So how the movie is working, and upon photoexcitation, it gets to. In this example, it was more than one excited, and then it has certain kinetic plus potential energy, and then it drifts away. So it's much bigger distance than interatomic distance, so it corresponds to already fragmented, dissociated molecule. Good. I hope this is the last slide. Right. Now let me invite everyone to open MATLAB. So the code name is LAB7 it just, this code is not very informative, the title, because it was updated multiple times. In order to keep it working, there are a couple of data sets, but they're not needed. I just didn't have time to update and remove. Just have them, these data sets, in the same directory where you are running the code. So after you have this code ready, let's make sure that it is running. So click on run. And then there are several instances of time where humans can breathe and prepare to watch something interesting, and then hit enter. So it tells press any key. It is not stalled. It is waiting for human to to push any key. Then it stays busy for some time. Okay, yeah, I'll approach you and do things. Okay, and you see it reproduces the movie that was demonstrated on the slide. It's a little slower because it's actual computation rather than demonstration. So I will make a tour around the seats, make sure it works. Steven, if you want to play anything, you can just use this laptop. If you don't, just wait until you get to your station. And I'll first approach Amos because we need to fix his CCast thing. Who else is doing MATLAB on CCast? Oh, you did before. Okay. So if I fail to help Amos, you will be the next resort. Can I sit here?
Yes, sorry.
Wow, it's heavy. Probably there are several important books. No problem. No problem.
So this one though, I just tried it now, but do I have to remove this?
Wait, did you save these files to the same directory?
I saved it to my. I have a folder for PChem.
Physical. Okay, would you please show me how you were saving the files?
So I've been saving it in my physical chemistry math lab folder,
So,
but I think
where are these files that?
these ones.
No. The ones that mention UN data. Put them to this directory as well. Just move them from or copy them from other directory to here.
Okay, so that should be like this. This for that last Wednesday project. Is it that one you're talking about? For
No,
UN
no,
data?
no, no,
Oh,
no.
I see. I didn't see it. Sorry. The one from.
Let's go to yes to the email.
So, yeah. Oh, this data.
Yes.
Sorry. Okay.
Please save them to
I'll
the same
save
directory.
it.
Yeah, I'll watch you doing it. And this one, and I'm always forgetting, but some of you may be curious about like grading and grades, right? So my goal is to get highest grade to everyone, but I just need you to help me to do it. So if you do, we have like 2 midterms. One is past, another is Monday, one final, and a couple of quizzes and homework. So midterms and finals each 30%, homeworks and quizzes 10%. If you just participate in everything, you should get to the A easily. Okay. If by some reason you cannot come, then it drops you by 30%. Good enough? Okay.
So it worked. So
Okay.
this one, and then I'll push in the key. So it seems like the computer is handling it better today. The other day it crashed.
This code is much more efficient. The other one was more intense.
Okay. And then for CCAS, I just go online and go on the NDSU.
Right.
I'll talk to Haiti. So
Okay.
I think it's.
So press any key once again. It's busy and wait until it invites you to press any key once again. Busy, busy, busy. Press any key once again. What? Let's try once again. Why it is not happy? Okay. Stephen, if you know what you want to do, please go ahead and play with it. If you have no idea, you may just scroll through the code and try to navigate where the Morse potentials are defined. That's what I was trying. Yes. Oh, yeah. And can you just, I don't just sitting so comfortably, can you just show this figure and attract attention of everyone to this blue figure? Just tell what it is. And maybe you can tell how you interpret it. Yes, probability distribution for the bond length. And which process does it describe? Like at time 0, the bond is like 2 whatever angstrom units. How does it change over time? Yes, it stretches and dissociates. Yes. Everyone is happy with this figure? Just globally and strategically, you do not oppose it. Okay, good. Okay. Okay, I'll fix it. So line 437. Maybe it will happen to everyone else. 437. Yes. Okay. Yes. So probably this error will happen to everyone absolutely, and there will be errors across the class. So you'll be the first. So I remove the path, save it once again, and rerun. Yeah. Right. Maybe a few lines below. Just keep, Stephen, please keep going. Yes. Okay. Line 57 is one of the potential energy surfaces. You may highlight it and we may discuss it together. Okay, wow. It goes now.
Thank you.
Okay. Yeah, if you do not parameterize potential energy surfaces all together, then we are doing excellent with time. So based on talking to Amos, I identified that the code may give an error for the line 430 something. So Stephen, would you please go to line 430 something, 430? Okay. It needs my finger. If we would be in the horror story, you can kill me, cut my finger, and apply it to the computer. Okay, so you see there is an many things. You can stay here and play further if you want, because I will be touring. So you see it tells, it is what Mel was teaching to us, right? How to save videos. And it tells what is the file name. Since I was working on this computer, I put explicit path. But if you would remove it, just give only file name, then it will be working. So the problem that it was not finding this path because it was like personified sets of directories on my computer. So if you remove it, it will start working immediately. Okay. Yeah, please try it. And now I'm going back to the very top, something like line 50 or whatever, where Steven was showing. Ding, 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 ding. Okay, so one of those. So maybe the best way would be just to hand draw on the PowerPoint. Insert new slide, blank. C, Control V. Okay, draw. So I'm going to convert this typed equation into handwritten equation. So here I just, okay, by some reason it is z. It is function of x, and it is equal constant, which we call dd. I don't know, maybe single d would be enough. Then there is an exponential. Let's track the brackets. So inside little brackets, outside bigger brackets, very outside very big brackets. Okay, so we have this big brackets, power square plus energy offset and what do we have inside the brackets? We have 1 minus exponential, and in the power of exponential we have minus x minus x equilibrium, and it has a constant. I think the better to use the letter beta to be compact. So let's think what this equation corresponds to and what is the meaning of each parameter. So basically, the data that you have collected needs an addition of Coulomb repulsion. And then after we get the potential energy surfaces, they need to be fit into this equation by selecting parameters x equilibrium, beta, d capital, and energy offset, four parameters. So the maybe I should try drawing this function. So if I just draw e to the minus beta x minus x equilibrium on the y-axis, and here is the x. X equilibrium. So it is exponential with negative power, which means if the beta equals 1, it will go through value 1x equals x equilibrium, and then it will go in a decreasing way. The beta changes the curvature of this, right? So it gets as more steep or more shallow. Now, if we are taking this, if you subtract 1 minus this function, so 1 minus e minus beta x minus x equilibrium, So it should be 0 at this x equilibrium, and then it will be negative here and slightly bigger there. Okay. And then next step is to make square of this. Square means there will be no negative. Everything negative will become positive, and then there will be no sharp edges. So it will make it shallower. Go here, go there, right? So for the square, it will be this shape, which already looks reasonable, right? A curve is a minimum. And then this, so we already took care of the square. And now we do have a factor d, which basically defines how high this edge when x goes to infinity offset from 0. So basically it is d parameter. So it shows how much energy one needs to insert into the molecule to have dissociation from equilibrium to dissociation regime. Make sense, Arena? Okay. And the last parameter, the delta E, it just brings this curve upper or down, just shifts everything based on where we excited should be higher, ground should be lower, right? So the beta defines the curvature. Is it shallow or sharp near equilibrium? Beta. D tells the energy for dissociation. X equilibrium shows equilibrium position. Okay, make sense? Whew. So did everyone got the code running? Okay, I'll use time to make sure that it runs at all seats, and then Mel, Hamidullah, I will be with you. I just want to check. Mel, does it run on your end? You can type or answer. Just let me know if it doesn't work. I'll try to fix. I'm going to talk to Hamidul first, and then I'll return to you and ask you to share screen if you want us to fix things together. Sure, please.
This one is running, but then there is some problem. I ran it before. There was some problem in these lines. 630 and 620, line 368 and 621.
Okay. Let me tell to everyone, MATLAB is quite, it's a good, reliable code, but it gets a little nervous if one tries to contract or expand the window where the movie is being generated during the time. So if you try to enlarge it, it will panic and tell, no, I cannot save, right? So if you are not saving movie, it's fine, it will continue. But if you're saving, it tells, no, we do not work this game. The amount of grid points, the size of the saving screen should be the same across the whole simulation. Okay, so likely if it gave an error, it means you were trying to expand or contract. But if it is critically important that the movie is being saved and working for Mel and for Steven, who will practice this code. For others, it's also important and cool, but not as critical. Mel, would you like to unmute the microphone and maybe share the screen if you feel comfortable? Okay, I don't know. Maybe there is no feedback. There is no sign. So, Steven, if we need to make sure that this dynamics is represented at a time of presentation. So, if something will not work at Mel's side, then you will be saving the whole class of showing it. And please contact me. I'll be happy to contribute. Yeah, okay.
I've seen that sometimes we get into errors, and if we run it again, it just works fine.
Okay.
One question.
Yes, please.
So the thing I'm presenting, distance, equilibrium distance of the ground state.
Yes.
That's what code should I run? The last one or the previous one?
No. I will explain to everything because there are several people presenting the similar subject. So if you're having fun running MATLAB, please continue. I just answering to a question of Hamidul, and maybe someone else would be interested. Like maybe Morse, Abdullah, and Haley would be interested. So the subjects from 5 to 8 all depend on the data from LoLA, right? So LoLA is when you complete adding the Coulomb repulsion to your data set, please share it with the whole class, and next 4 presenters will use your information. Of course, if Hamidullah, Mos, Abdullah, and Haley are impatient, you can try to regenerate data, but it's maybe more efficient if you do just little shares, each of us, right? Hamidullah was asking a question like, which code should I run? The first one for eigenstates or the last one for dynamics? Right? The answer is none. None. You are not running the codes. You are analyzing the data and explaining them. I don't know, is it harder or easier? But Haley will try to extract this d beta x equilibrium and energy offset from the data of LoLA, right? And if you want to do things after Haley has done, you can just borrow the value of x equilibrium from her. But maybe you do not want to wait it because if you see the data from LoLA, you can identify where is the minimum. Just take this number and compare it to what you find online for actual hydrogen. Okay, so analyzing, you're not running the code, you're analyzing the data. Make sense? And I don't know if it is easier or more complicated. It doesn't mean you do nothing. It's okay. Oh yes, please. Yes, please. So any other other questions? Okay. So code is working at each side. Super. So please do not hesitate to send me emails. I do not promise to answer immediately, like within minutes, but I promise to read them and maybe answer with delay. And I really love reading these emails because they show me if I missed to explain something, and I will try to answer as soon as possible. And it's my best interest that everyone makes nice presentation, and I maybe worry of success of these presentations more than presenters. Okay, it looks like I was scheduled to be in class until 12:30. Yeah, I think we have moderate success in getting strategic planning, in making sure that everyone is acquainted with the code. And personally, I failed to do the tasks of Lola and Haley today in class myself, which I was planning to. But send me emails. I really want to cooperate with all of you on having things done. And if you, I'll probably chat to the next the instructor of the second half to make sure. Right now, we are working on the assumption that next Wednesday is our last meeting. If I learn that it is not truth and we have more, we can loosen our schedule a little bit. Just do not plan on it, but as if opportunity pops up, we will use it. Okay, so many thanks to all of you. I think you are doing really great in this class. I hope that you will develop positive memories. I have no doubts that you will get great grades. And my best dream is that some information and ideas will stay with you a little longer than in undergraduates who are bringing ball of knowledge to the exam. Okay, yeah, meeting is done. I think it is the last time I'm speaking as a primary speaker in this class. Next 2 meetings, you will be speaking and I will be just announcing who is the next speaker. Okay, thank you. Well, I'm going to disconnect. If you oppose, if you want to ask questions right now, feel free.
Oh, I don't have any questions, but thank you for still having Zoom. I'm sorry I wasn't in class. I was
Not
having
a problem, not a problem.
day.
Okay, was the code running well on your end?
Yeah, I was able to do it. So
Super. If something doesn't work, let me know, and we may set up a personal one-to-one Zoom meeting to make things working. I'm really
okay,
willing to.
sounds good.
Okay, if you
Thank
don't
you
mind, I'm
again.
going to end the session.
Okay, bye.
Okay, bye.